Unlike major crops such as wheat and corn that have been fully mechanized, specialty crops such as apples are still harvested entirely by hand.
Labor shortages and labor costs are impacting agriculture in our backyard here in Michigan and across our country in a big way. So automation is needed, and it's needed right now.
Our robot is an AI-powered system that gently sees, reaches and picks apples from the orchard, just like how humans pick apples.
Look at that cost per acre, cost per hour. It greatly reduces both of those. And it also can help boost revenue because it's producing a higher quality fruit with fewer bruises. And it's more consistent and more reliable. When comes time to that 90-day window to harvest the crop starts, you need to have labor available and on demand.
And we also make the whole system really modular and cost-effective because the economic viability is also very important for the growers. MSU technology really helped us in securing our IPs and providing commercialization guidance, also connecting us with the industry partners.
If industry isn't there from the early stages of the development of the technology, I think as a researcher, you don't know what the real needs are, what the real issues are.
The MSU Innovation Center has helped a lot with the mentoring on our pitches and how we talk to potential investors.
This award not only belongs to us, but also the students, mentors, as well as the partners throughout this process.
Receiving this award, it validates years of innovation, and it shows that we have a technology that can solve a real problem, and people recognize that problem and recognize the solution.
It's definitely a great honor to me, and also it reinforces the importance of translating fundamental research to applications of real societal impact.
So I think that the fact that this is the second year that mechanical engineering faculty have gotten this award really demonstrates the breadth of the research that we're doing in mechanical engineering, and I think it also demonstrates that mechanical engineering is still the most general of the engineering disciplines. Congratulations, you've made all of us proud.
When we do research in medicine, 99% of the time, we don't have access to humans to do biomedical research. And the reason for that is because we need to do experiments that would not be ethically acceptable in a human. That is a limitation that is never going to change, and for good reasons. The problem then arises, if I want to study human conditions, how do I do it? Instead of working with mechanical parts, you could think that the parts that we work with as engineers are biological parts. So the technology that we develop, what we call heart organoids, or in more layman terms, mini hearts, right? What this technology does, it creates the opportunity to work with human organ-like structures in a dish. And the potential for that to advance biomedical understanding, mechanisms, and drug development and therapeutics is just massive, it's still untapped. One of the most recent and impactful ones, it's a heart organoid model of human atrial fibrillation. With our model, we can study atrial fibrillation in a dish, and we can develop cures for atrial fibrillation. You might be wondering, why that now and not before? Why couldn't we develop cures for atrial fibrillation before? This is a condition that for the last 40 years, we haven't been able to develop drugs to treat because we just couldn't model it accurately. Now we have a model where we can actually study atrial fibrillation and do compound screenings, pharmacological screenings.
Our ultimate goal is to make an impact in the real world. Aitor's work in the organoids field is a role model almost to move from scientific investigation and to the real world.
MSU Innovation has been critical to help us navigate the industry space, to make sure that your intellectual property is protected and that we can move to the next steps. Once the technology is disclosed and MSU starts the patenting process, it's been very useful working with the technology manager to act as a link between us and the industries that are interested in the technology. It's a privilege and it's an honor to receive these recognitions from MSU.
Congratulations, Aitor. We're very proud of you, and as a department, we're so proud to have you here.
Industry are facing rising energy costs, tightened environmental regulations, and growing pressure to reduce carbon emissions for all kinds of technologies. And in this couple of years, a specific the process, a integrated biologic and electrochemical technology has been developed at MSU Anaerobic Digestion Research Education Center. The technology is about simultaneously generating carbon and nitrogen-based energy products from the waste streams, really developing energy self-sustained the systems to convert those organic wastes into valuable products.
Scale up and translation of the technology to practice is really baked into all of our DNA, and Way exemplifies that more than probably anyone, which is we need to partner with a company to first understand their needs and then say, okay, what is the suite of solutions that will help meet that need or solve that problem? And he really takes that approach, partnering with those companies and really listening to them and translating that information in a level, which is often dollars and cents, that is the language that's relevant to the corporate partner.
The Innovation Center has been essential in providing the structure, guidance, and support needed to build strong corporate partnership.
You know, the importance of the Innovation Center, Business Connect, all of those teams at MSU is for faculty to really know when is the work I'm doing important relative to intellectual property, what's the value of that, and often when you work with a company, sometimes they're bringing something to the table and you have to meet in the middle.
Their support allows researchers like me to focus on science, engineering, turn ideas into a real collaborations that work. It's a great honor and deeply meaningful to me. But I see this award actually is not only for myself. I truly see this as a team award.
Way, on behalf of the entire faculty, staff, and students in the Department of Biosystems and Agricultural Engineering, we congratulate you on this award. It really brings recognition to the amazing work you've done, but it really sets an example to inspire all of us to continue to pursue partnerships with corporations or any entities where we can have an impact on the world. So thank you for the work you've done, and congratulations on this recognition.
Not training against drones is something that we've really seen as a huge problem. It's really evident in the Ukraine-Russian conflict. About 80% of all casualties are coming from small unmanned aerial systems. There's no low-cost but highly maneuverable drones made here in the United States for different defensive systems to actually learn and train on how to defeat drone technology.
You basically select how many drones you want to fly, how aggressive you want them to fly, and then you select like a geofence and press go, and these drones are all deployed into like a cloud or like a hive of bees. We want to emulate that fast-moving threat that you'll see out on the battlefield.
The big difference that we really like to highlight is the ease of use of our systems and the modularity.
We first pitched our idea at CES in the beginning of 2025. We ended up pitching our idea to a few high-level representatives in the Army and actually ended up winning. This direct validation from the Army and directly from the customer made us realize that this is going to mean a lot and we can impact a lot of soldiers' lives.
After that, we participated in an event in Grayling, Michigan, getting direct feedback from the warfighter, doing warfighter touch points.
Is there a way that a drone can do X, Y, and Z? We have our printers on site and we come back in a few hours and say, is this what you were thinking? And they just about drop their jaw and say, how'd you do that so fast?
It's awesome to be recognized as a Student Startup of the Year. Just all the helping hands we have here at MSU.
It was wonderful to be named the Student Startup of the Year, and there's been a ton of help along the way from the Burgess Institute.
We walk them all through the same process, through a discovery and launch process. We infuse them with resources of internships, CAD work, legal help, and then we also give them resources of funding.
As a group of co-founders, all engineers, we're super talented and super experienced on the technical side, but when it comes to the non-technical founder things like actually pitching, interviewing,
they helped us expand AG3 Labs into a profitable business.
AG3 deserves being a Student Startup of the Year because of their grit, of their passion, of their push. Guys, congrats, AG3, amazing, love the story, and cannot wait to see what happens in the future. Congrats again.
SwitchSource is a company manufacturing a new type of smart grid equipment. We think of distribution utilities as collections of distribution circuits. It's how they deliver power to customers. That distribution circuit is about 5 to 10 miles of this 3-phase backbone. They run what's known as a single-phase lateral out to those customers. Something like 50, 60, 70 miles of single-phase laterals. It is very difficult for the utilities to balance all 3 phases equally when they have all these different single-phase taps.
So this is a device that we call the Phase EQ. We liken this to a 3-lane highway. What we are doing is introducing a tool that acts as like a dynamic interchange point on the grid so that the traffic can more freely reconfigure and rebalance. And what you're left with is a more balanced and reliable system, but also as much as 25% more capacity.
SwitchSource was selected as this year's Innovation Celebration Startup of the Year because they're at a critical point in their journey. This company was licensed technology from the university 10 years ago. They've got roughly $80 million in committed contracted revenue for a total of 240 units that are expected to be deployed into the field in the next few years. So we're incredibly excited about what this technology can mean to the utility industry, and they're really at that inflection point of the hockey stick growth to really show the world the power of the solution.
Michigan State had come to us with the IP, with a good idea of how a licensing structure would work, customers, potential funding source, technology, all ready for us. They were very invested in our success. They did a tremendous amount of hand-holding, including going back and looking at the license with us, many times afterwards.
To be recognized in this way, to be able to celebrate the company's progress to this point, looking back and knowing how far we've come, all that we've endured along the way, it's been definitely a roller coaster. But having been able to start that journey with MSU and now being recognized as one of those companies that they see as being a success is something that I am very proud of.
Charlie and Lane, it has been a sincere pleasure getting to know you guys over these past months. Keep up the amazing work. I know you have an amazing pipeline of additional products ahead, and I can't wait to see SwitchSource become a household name for utility companies all around the world.
Most people don't realize that the foods that we consume have been being improved over the decades. We're the scientists behind the scenes creating potatoes that are actually better for the farmers, better for the industry, and ultimately the consumers. When I first arrived, the industry laid out what were some of the challenges that they had. Scab is a soil disease that reduces the profitability for the farmer because the potatoes are damaged. We have about a half a dozen varieties that are quite successful in the industry. One of them is the variety Manistee. Manistee stood out because of its resilience. For the farmers, making it more economical for them to produce their crop. For the industry, that means that might be the processing traits that make it more valuable to them in the plants and makes their processing more efficient. And then the consumers, they benefit because they get a product that is of higher quality than in the past. The university has an expectation that we're going to do research, and the MSU Technologies Office is a place where we can go if we have research that translates to something of commercial value.
What we could do here at MSU is to help the scientist navigate the process of getting a patent, and then with that, then become licensed. That's important because with the different commercial producers, they want to have something that's uniquely their own. And then the pipeline to go through that patent and licensing process really does create a positive feedback loop that supports innovation in the scientific space. It's really that tech transfer piece that's actually going to get it out the door in a way that's usable, but also to have it benefit the growers.
When I look back over my career, I can see that it's varietal changes that really drive the industry forward. It's really nice to hear from the farmers telling me how well Manistee has performed for them, and they're thankful to have a variety like that. As a plant breeder, boy, that's gold. And so it was that work 10 years ago, working with MSU Technologies, with Business Connect, and getting that partnership in place that allowed us to get this work done. I'm honored to receive the award. I think it represents our program. We're part of the land grant mission. I've always believed in that, and I can't imagine this work being done at a non-land grant university.
Congratulations, Dave. This is a really important and impactful award. I'm really happy for you.